For our next talk, it's Assaf Gelber, optimizing your poker game with the help of Ruby. Round of applause.
Hi everyone. So in this talk, we'll be talking about beating poker with the help of Ruby. First of all, how many of you have actually played poker before? Nice. How many of you have lost money playing poker? So hopefully after this talk, we'll all be a bit better poker players. My name is Assaf Gelber. I've been a Rubyist for the past 4 years. And I've also been an amateur poker player for the past like 5 or 6 years. And this connection between poker and math and programming in math has always brought me to trying to optimize my game with the help of the Ruby tools that are available to us as programmers. So right now I work at the PayPal Consumer Product Center in Tel Aviv. We're building the future of PayPal consumer products for over 160 million people in 210 different countries. So this is a poker talk. Koichi's talk was very like Ruby technical. This is a poker talk. I'm going to enjoy it because I love poker and I enjoy playing poker. You may not, but listen anyway. I'm going to start with a slight introduction to poker, so whoever you that hasn't played poker can just know what we're talking about. For those who do know poker, this is time to tweet about Koichi's talk or whatever you want to do on your phone. So we're only going to be talking about no-limit Texas Hold'em poker, which is the most popular variation of poker at the moment, out of many different variations. So a lot of people, when they think about poker, they think about the James Bond movies, right? Casino Royale, the villain sitting in front of James Bond and just like staring in the eyes, and he's saying to himself, his nose just twitched, I'm going to go all in, he must be bluffing. Well, it's not like that. It's mostly nerds sitting in front of their computers, no offense to that guy, like playing 12 or even 16 tables at a time. And in each situation that they are, they try to determine the most statistically profitable decision. And we're going to be talking a lot about this statistically profitable decision today, and how we can make that decision. So a hand of no-limit Texas Hold'em poker looks like this. Each player has 2 cards that are called the hole cards, which are privately held by him, only exposed to him, plus 5 community cards, which are exposed to everyone on board. And hand of Texas Hold'em looks like this, right? So each player is dealt 2 cards, again exposed only to him, and then a round of betting occurs. A round of betting basically means each player in turn has to make a decision that will affect how he moves on to the next round of betting. So, for example, if one player bets $20, the other player has to decide if he's going to call $20 to move on to the next round, if he's going to raise to make the other player have to call to move on to the next round, or if he folds, which is basically just forfeiting the hand, and if all players fold but one, that one player left wins the spot. So assuming both of these players called each other's bets and moved on to the flop is the first 3 cards of the 5 shared community cards, and now another round of betting occurs. Whoever moves on to the turn card, which is the 4th shared community card, goes on to one more round of betting after this card. Whoever stays in the hand goes on to the river, which is the last of the 5 community cards. And one more round of betting here, and assuming everyone hasn't folded, we go on to showdown. Now, in showdown, each player exposes his hand, and we see who wins. So the hand rankings are hot card, which is the least valuable hand in poker. I'm going to be throwing these around a lot later on, so try to remember some. High card, which just means I have a high card in my hand, and the value of my hand is determined by that card. One pair, which is just 2 cards of the same rank, and again, in case of tie, if 2 players have the same pair, the next cards of descending rank are what determines the value. 2 pairs, 3 of a kind, straight, which is all 5 cards in ascending order. The value here is determined by the highest card in your straight. So straight from 4 to 8 would be weaker than straight from 5 to 9. Flush, which is all 5 cards in the same rank. Full house, which is 3 of a kind plus another pair. 4 of a kind, and a straight flush, which is the strongest hand, which is all 5 cards in order and of the same suit. So back to our case, the first player has a flush, right? 5 cards of the same suit. He has 5 diamonds in this case. And player number 2 has 3 of a kind, with the 2 jacks in his hand, plus the jack on the board. So in our case, player 1 would win. So you almost say to yourself, well, that's easy enough, right? Cards are drawn from the deck, and on the table, someone wins. It's completely a game of luck, right? Why would I need math for this? Now, to prove that you do need math, I'm going to look at a specific situation. So again, player 1 has 5 suited diamonds, player 2 has the 2 jacks. On the board, we have king of diamonds, 8 of diamonds, deuce of clubs, and ace of spades. The pot is $100, and player 1 just bet $20. Now, player 2 here has to make that statistically profitable decision that we were talking about earlier. So let's go through the thought process here to determine that profitable decision. So there are 8 cards already out of the deck. There are 52 cards in a deck of cards, so there are 44 remaining cards from the deck. In order for player 2 to win, he has to catch that last diamond, the 5th diamond to complete his flush. We already know that there are 4 diamonds out, right, 2 in my hand and 2 on the board. There are 13 diamonds in the deck total, so there are 9 remaining diamonds. So our chances of getting that last diamond on the river is 9 out of 44, which is around 20%. The bet was $20, so we need to pay $20 to win the $100 in the pot, plus our opponent's bet of $20. So we need to pay 20 to win 120. Like I said before, our chances of winning are 1 to 4. We win once for every 4 times we lose. We're being paid 1 to 6, right? So we're being paid better than our actual chances of winning are. So in this case, this is an easy call. Again, you must be saying to yourself, that's easy enough, right? Thomas Bayes, the guy in the background, he taught us Bayesian statistics. I can do that in my head, right? Just 9 cards remaining on 44. That's pretty simple. So why would I need Rubik's? This is RubyConf after all. So let's look at one more situation. Again, 5 6 of diamonds versus the 2 jacks, $100 in the pot. The bet is $20, but this time we're before the flop. We don't know any of the exposed cards. So let's take the same thought process that we took before and try to determine that statistically profitable decision again. This time we only know 4 cards, so there are 48 remaining cards in the deck. There are 34,246,080 different possibilities of a flop, turn, and river. That's 34,246,080 different possibilities. Some of them will give us the win, and some of them will not. Which one will and which one won't? I don't know. That's way too much to be able to figure out in your head. So this is why we need something to help us. So we have poker calculators. Poker calculators, they basically let us input a certain situation. So for example, here we have the 5 6 of diamonds versus the 2 jacks, and they will tell us what each player's odds of winning are. So in this case, we see that the 5 6 of diamonds has around 22%, and the 2 jacks has around 77%. That's right, but how do they work? Well, super cool math, obviously. So this is like the first technical topic in this talk, which is the Monte Carlo method. The Monte Carlo method is a statistical analysis method, which is used for a lot of different things, which basically means do random stuff and draw conclusions. So if we're in a certain situation, we can take a whole bunch of random outcomes of that situation, look at the results that we got, and determine an approximation of the actual statistical situation. Now this sounds really, really silly, but it's used in quantum physics and fluid dynamics and computer graphics and AI for different games. It's really a reputable strategy for statistical analysis, and it works in this situation as well. So we're going to look at the hello world example of the Monte Carlo method, which is making an approximation of the value of pi. And we're going to do that with this diagram here. We have a square, which is 1 by 1, and enclosed inside it is a quarter of a circle with a radius of 1. So the area of the square is 1 squared, and the area of the quarter circle is 1 squared times pi divided by 4. So we know that the ratio of these two shapes, the ratio of the areas of these two shapes, is pi divided by 4. Now, if we were to take a whole bunch of random points inside the square and see how many of them fall in that enclosed circle, that ratio is going to be the same as the ratio of the areas of those shapes, statistically speaking. So if we were to take that ratio and multiply it by 4, we would get pi approximately. So let's see how this works in code. Firstly, we're going to gem install Monte Carlo, which is a gem that lets us run Monte Carlo simulations pretty easily. It also gives us a few utility methods to analyze those results. So let's hit code. That's it. We're just going to define our origin point as the bottom left corner of the square. And we're going to run an experiment. We're going to run it 1 million times. And each time we run that experiment, we're going to draw a random point inside that square. So our point will be somewhere between 0 and 1, which is the area of the square. And we're going to calculate the distance from that point to the origin. And if that distance is below 1, we know that that point is inside the quarter circle, so we're going to return true, and otherwise we return false. Now, we're going to look at the probability of getting true in our results, and we're going to multiply that by 4, and we get pretty close to pi. That works, that's not bad. So take that, Archimedes. We just did, in around 8 lines of Ruby, what he did with a bunch of polygons and a few years of figuring out different ratios. So that's 1 point for Ruby. So let's do the calculator. But first, hand ranking. How do we know in code that one hand is better than another? So I've seen 3 different ways to do this. The first one is the boring decremental way, where you would just go through a set of rules for each hand and determine if your hand falls into that rule set, then that's the value that you have, from the strongest value to the weakest value, which is pretty boring and pretty slow, but it works. The second way is the cool regex way, which you saw implemented in a Ruby gem, actually, where he would just take 5-card hands and encode them as a string with 3 characters representing each card. The first character is the distance between the current cards and the previous card. So we have 0 for the first card, and then 2, which is the distance between ace and queen, and 4, which is the distance between queen and 8, and so on. The second character is the actual rank of the card, and the third is a character representing the suit. So we have hearts, we have H for hearts, and C for clubs, and so on. Now, he has a bunch of different regex patterns that would match each of the possible hands. So the first regex is 4 of a kind. We search for the rank of the card, and then we go through and look for that rank again. So if we have 4 cards of the same rank, we know we have 4 of a kind, and same with the straight and the flush and so on. And he had like a bunch of different regex patterns for each possible rank, and I thought that was pretty cool. The third way is the fast bitmask table way, which does require you to do a whole bunch of computation in advance, like at compile time. You just need to create a huge table of the different hands and encode them in a certain bitmask way and find their value in advance. But after on, you can just like do a simple table lookup. This is really, really cool and really, really fast, but way too much to show in one slide. So just head on over to the GitHub repo if you want to see that. So let's build a calculator. Now we know how we can rank hands. That's it. So again, we're just going to instantiate the deck, and we're going to draw the 2 hands that we want to match up against each other. In our case, the 5, 6 diamonds against the 2 jacks. We're going to create an experiment. Again, run it 1 million times. And each time we're going to draw 5 cards from the deck to act as our shared community cards. And we're going to set that the community cards on each of the hands, and we're going to compare the hands. So this operator will return 1 if the first hand won, -1 if the second hand won, and 0 if they tied. Now after we've done that, we're going to look at the probability distribution of the results that we got, and we see that we get pretty close to what we saw in the calculator. -1, which is the 2 jacks, won around 78% of the time. The 5-6 diamonds won around 21% of the time, and they tied a very small percent. So this works just like the calculator would. Well, too bad it's not that easy. There are 2 things that we didn't take into account here. The first being, we don't know what our opponent is going to do in the next round of betting, right? So we know we have to call $20 now, but in the next round, he might bet like $500, and we're going to have to call that again, even if we didn't hit our hands, if we want to continue on to the next round. So that might really change our perception of the hand in the previous round if we knew he was going to do that. And the second thing is that we don't really know what our opponent has. A hand of poker basically looks like this to us. We know our cards, but we don't know what we're playing against. So making that decision is much, much harder. So, in essence, poker is a game of ranges. We don't know what our opponent has exactly, but we can estimate a range of hands that he might have in this situation. Now, the better poker players we are, and the more we know our opponent, we can narrow down that range more and more. And the narrower that range, the more we have a better understanding of our opponent's hand and our odds of winning in that situation. So if we knew our opponent really, really, really well, and we played like thousands of hours with him already, and we know that each time he bets $20 with $100 in the pot, he has a pair in his hand, right? He has 2 cards of the same rank already in his hand. So now this situation would look to us like this. We don't know exactly what he has, but we estimate that he has either 2 deuces, 2 threes, 2 fours, and so on. Now against this range, we can still figure out our odds, because if we know our odds against each of the hands in his range, we can still figure out our chances of winning approximately. So narrowing down that range as much as possible is really an essential tool for us to be able to win at poker. So how can we actually narrow down that range? Well, we have hand history. This is only true for online poker, because in online poker software, we can just get a whole list of all the hands we've ever played against each of our opponents, and then we can parse that using Ruby and get some very key insights on all of the opponents we've played, and then we can look back at those stats in real time when we're playing those opponents and try to get a better understanding of them. So there are 3 main insights that we can get from this. The first one being what he's actually likely to have. So if we've played against this opponent like thousands of hands before, and we've been in a specific situation a few hundred times, and each of those times he had a very small range of hands, or even one specific hand, we can be fairly certain that if we're in that situation again, he has that hand again. The second thing is what he's likely to do. So again, if we're in a situation and he did the same thing over and over again each time, we can be fairly certain that he's going to do that again. And the third thing is how he's likely to react to the things we do. And this is very important to our understanding of our opponent as poker players, because we know that if we raised him every time we were in that situation and he folded and let us win the hand, if we raise him again, we're fairly certain he's going to fold here too. So this is very, very important to our understanding of the hand and can really, really improve our game. So this is super, super critical to our understanding of the game, and it only takes a little bit of parsing in Ruby. So I'm going to show 3 main stats that can really help us understand our opponents in real time. So we're just going to load up our hand history, and we're going to search for a specific opponent. This time we're playing against J-Bonds 007. And the first stat that we're going to look at is VPIP. Now, VPIP stands for voluntarily put money in pot. This basically tells us how many of the hands that were dealt to that specific player, he decided to play. He didn't fold right away. And statistically speaking, he's not going to get a good hand every time. So if this number is very, very high, meaning he plays a lot of different hands, we can assume that he's going to play with a wider range of hands that aren't necessarily that good. And the opposite is true here. If he only plays a small amount of hands, we can be fairly certain that the hands he's choosing to play are very, very strong. So we know how to adjust our range that we think that that the player has according to this number. The second thing is the aggression frequency. Aggression frequency tells us how many aggressive plays this player makes. So if he makes a lot of aggressive plays, we can be pretty wary calling him in early rounds because we can be fairly certain that he's going to raise us and make us call more money on later rounds. And if we don't want to put a lot of money in the pot, we can be wary of that in advance. And the opposite is true here. We know that if we have a fairly weak hand now, but we might hit a straight or a flush later on, we know that we're not going to have to put a lot of money in the pot in later rounds of betting because he's not very aggressive. The final cool thing here is we can actually see the hands that he's reached showdown with, the hands that he's exposed to us. So if he reaches showdown with a lot of very weak hands, like one pairs or even just high cards, we can know that if he's calling us and going on to later and later rounds of the hand, he doesn't necessarily have a very strong hand. We can still beat him with like 2 pair or 3 of a kind. But if he's only reaching showdown with like flushes and straights and full houses and so on, we know that if he's calling us right now and we're pretty close to showdown, he probably has a very strong hand and we don't want to play against we're absolutely certain that we can beat him. Now these 3 things are just like the tip of the iceberg here. There are so many different stats that can really deepen our understanding of the players that we're playing against. And we can parse all of them out of our hand history and look at them in real time and really understand the guy we're playing against and help us make more statistically profitable decisions. Well, again, too bad poker is not that easy, right? Poker is a game of extremely intricate strategy, and people devote their lives and play like 10 or 12 hours online every day just to get better at making those statistically profitable decisions. And I do assure you that if you analyze your hand history retrospectively and look back at the plays that you've made and try to analyze the other players, you will be a better poker player, but it doesn't guarantee you to win. So I do urge you to try, but please don't blame me for all the money that you lose because of this talk. So thank you very much. Questions? Anyone? Is there a casino on the island? Yes.
Have you used this?
Definitely, all the time. There is what's called a HUD, heads-up display, which when you play online, it just like shows you on top of the table that you're playing all the different stats about all the opponents that you're playing, which is basically cheating, but still. You can see all of the different hands you've played against every opponent sitting at your table, and just by looking like at their name, you can see their VVIP and their aggression frequency and all that. So every time you make a decision, you can just look back at the different stats and try to understand that player without having to know them at all if you've already played enough hands against them. But this is really dependent on the sample size that you have. So if you've only played with a player like 10 hands, that's not really saying much. But if you've played thousands of hands with him before, you can really understand his game just by that little window that's next to him. Anyone else? Yeah?
Not a Ruby question, but what would you recommend?
This is a poker talk, it doesn't have to be Ruby.
What would you recommend, like a book to like describes inner mechanics?
Books. That's a difficult question. There are many. There are many great poker books out there. I think Doyle Brunson wrote a great one. Doyle Brunson. He's a very old and reputable book player. I don't remember the actual name of the book. Thank you very much. Super System. Super System and Super System 2, I believe. So they're a great start. There are lots of forums as well, 2+2 forums on the internet has like really loads of information about ancient. Right? Thank you very much.